take the lead on that sea ice article you sent? Why don't you take the lead on that?
Okay, so it's from EcoWatch. It's titled "World's Ice is Melting 65% Faster Than the 1990s." It says a first of its kind study has examined the satellite record to see how the climate crisis is impacting all of the planet's ice. The answer, quite a lot. The rate of worldwide ice loss has increased by more than 60% in the past 3 decades. A study published in the Cryosphere found, they say, quote, the ice sheets are now following the worst case climate warming scenarios set out by the IPCC. Okay. Sea level rise on this scale will have very serious impacts on coastal communities this century. Then I just want to skip down at just the idea of how much sea ice has been lost. It says the paper also broke down which sources had lost the most ice in terms between 1994 and 2017. Amounts are approximate in the U.S. tons, and then they list six. It's just the idea that I'll focus on the Arctic and the Antarctic. Antarctic sea ice lost 8.4 trillion between those years of sea ice. Antarctica ice shelves 7.2 trillion. Antarctic ice sheet 2.8 trillion. Oh my god! So then the mountain glaciers, ice sheets. So how do you feel about
Well,
everything going on?
was it that article that also said that when the sea ice melts, the sea level changes is not affected. If anything, and you don't forget, water expands upon freezing. So when it melts, it's actually going to contract. Now, if you want to say that because there's no albedo, and now
Right.
the water is absorbing the heat, then you have thermal expansion. Well, okay, then you can say sea ice, the loss of sea ice will lead to increased sea levels due to thermal expansion, not the melting of the ice itself. So if they want to
Oh,
specify it
okay.
that way,
I don't think
then
they
then
did.
I say okay, they're correct, but they didn't. So it's like, no, if you need to talk about in reference to thermal expansion.
Interesting, because yeah, good point, Jim. You got the eye for this. It's just the sun of the absorption of solar energy is warming the oceans up there as well. Oh,
Yes.
right there. As the ice shrinks, more solar energy is being absorbed by the oceans and atmosphere, causing the Arctic to warm faster than anywhere else on the planet. Um, it not only is speeding up sea ice melt, it's also exacerbating the melting of glaciers and ice sheets, which causes sea levels to rise. Well, they have it, but I don't know if they differentiate.
Yeah,
Okay.
sure. When you melt land
Okay.
ice, yes, that's going to contribute to sea level rise. But sea ice itself is not. It's from a quantity point of view, it's H2O neutral, whether it's in the
Okay.
solid or liquid state, except of course that ice does expand upon freezing. But if you're talking about heating the liquid portion of the water of H2O, yeah, then you have thermal expansion. So not having the ice there will lead to thermal expansion because of the energy being absorbed by the water. Now, remember some time ago we discussed how October is turning out to be the month in Alaska that's warmed the most? And
Yes.
and remember how I said it's because the ice is freezing up, the water's freezing up later and later because it's all that latent heat energy. So it has to give off that latent heat energy, which goes into the atmosphere, keeps things warmer. Zach Lay put out a tweet this morning saying the exact same thing.
Okay. I'll have to look at it. Oh my god. There you go, Jim.
Yeah, he put out, and that's why I think the last time we spoke, I changed, I shared with you that I've changed my assessment of how slowing down AMOC. I used to think that because the data tells us this, that it would bring on a new ice age or at least a cooling trend, and
Right.
now I'm revised that assessment because there's so much latent heat energy into the Earth's oceans down to 2,000 meters that yeah, that heat energy is just going to continue to be given off. So even if AMOC slows down or stops, the planet's going to keep on warming because so much heat energy has been absorbed by the oceans, and it's just going to output that into the atmosphere.
That's a horror show. I mean, that's just
It
it's
is.
the feedback loops. Oh, and just the carbon emissions taking on the life of their own kind of thing. Like we talked about the methane, uh, the feedback loops. Like they're creating more and more. The permafrost thaw. What was it? The rainforest is going to turn into a carbon source as well as the ocean. Like that's what you're talking about, right? Like things are starting
Yeah.
to they're becoming machines of their own, like warming machines of their own.
And don't forget, as as the oceans warm, gas solubility decreases with increasing water temperatures. So at some point, the oceans will not be able to absorb any more gases, and they've absorbed the majority of what we've released, by the way. That
Oh my goodness.
it's the absorption is going to stop, and the oceans continue to warm. Then the gas solubility, well, it's going to be outgassed. CO2, all gases will be outgassed back into the atmosphere. And here's the other thing, and we've touched on this before. If you stratify the oceans, and I got videos coming out on this, if you
Yeah.
stratify the oceans, the phytoplankton, after they use up the nutrients, are going to die. There goes primary productivity. There goes the food chain.
Extinction.
Yeah. And don't forget, phytos provide 55 to 80% of atmospheric oxygen. And
Wow.
they go if they
System.
die, you're going to lose that oxygen source. And scientists, chemical atmospheric scientists, have already measured a decrease in oxygen levels. They're measuring it now. Oxygen levels in the atmosphere
Wow.
are decreasing. And so the oceans are dying. So there is less output from the phytos. So they're contributing less O2 to the atmosphere. Here's the other thing, we're burning fossil fuels. What is
Continuously. Yeah.
used to burn fossil fuels? Oxygen. So we're using oxygen from the atmosphere to burn the fossil fuels. That is also a contributing factor to the declining oxygen levels.